Hello, everyone. Welcome to Earth Space Science. Back here with Mr. Campbell again to our second day of our second week, learning here all about our solar system material with regards to now some space telescope stuff. So as you guys can see here for our Go Blue, again, this is for Tuesday's video lesson. As you guys know, this week we are not going to have a video lesson on the last day of every week, because those will be assessment days that will be replaced with our unit quizzes, our assignments, etc., etc. So all the days we had for labs, for review days, for test days, and for test analysis group days, those are all gone, given that our class is now all fully online for the time being. So in order to keep us on schedule with the curriculum, like I said, those last days will be devoted towards those assessments, or submitting those assessments, I should say. All right, so if we look here, we can see announcement-wise, we've got the Unit 7 vocab due on Friday. Again, that list is on EDSB, as you guys have already seen. Showed that to you yesterday, 15 words, all about eclipse, the eclipse and the different lunar phases, things like that, right? Then we've got our notebook checks are going to be due on Friday as well. I will soon, probably maybe tomorrow, be posting what pages that I will request, just 2 pages that we worked on in these past 2 weeks with our e-learning for you guys to just take a picture of and submit there. We'll have our first kind of virtual lab next week as well. That'll begin next Monday. And then we are going to have our next unit quiz on Thursday. Again, that quiz will be posted on Thursday. Because we'll have one less day of material, it will only be a 10-question quiz. Let's go ahead and begin our Go Blue questions. Number 1, again, write those down on page 3. Pause this video as you see fit so you can record and get down the material and better understand it. What is the name of NASA's space telescope that has recorded detailed images of outer space and other galaxies? So it's able to look to the extreme far depths of space, right, for the first time in our recorded history. And then 2, what does this telescope use to record these images? Go ahead, pause the video, take a moment to answer, and let's go ahead and check our answers out. Number 1 was simply put, as we ended yesterday's lesson, the Hubble Space Telescope. So again, Hubble Space Telescope, a massively innovative piece of technology throughout our astronomy and our space research history. Okay, really providing us with our first ever detailed high definition images of other galaxies and other solar systems. So pretty incredible stuff there that we discovered just in the past few decades. And then 2, how does this measure, how does this record those incredible images? As you can, and this is the top right, we see that picture of the Hubble Space Telescope. I also had it in the previous picture up here from that high HD video I showed you guys yesterday, right? Well, what's inside of this are these massive, I mean, take a look at this picture, guys, compared to the humans here. We have a massive mirrors that are going to magnify light and images from billions of light years away. So these mirrors reflecting those images. Again, think of like a massive telescope just floating up into space. That is what's being used, those mirrors. Okay, those mirrors are going to be essential there. Okay, update table of contents, guys. Today we are going to begin pages 4 through 5 as Kepler's laws of planetary motion. So be sure to record that and have that down in your notebook as well, because I may just say hey, I want to look at the table of contents page as the notebook check, right? And for our third video question on page 2, again, if you don't have room, just put it on page 3 or make a page 3B. What would Earth be like if the sun doubled its mass? And I've got some other links here to look at with sun stuff, but I'm just going to focus on the second link here, which is the only video regarding this question, or the only video regarding this question that I did post to EDSB. So let's go ahead. Again, if the sun just suddenly doubled in its mass size, right, what would that do to Earth? How would that impact us? Probably not a good thing, right? I'm going to go ahead and give you guys a glimpse of that video. But again, be sure, because those video questions are going to be important for those notebook checks and for quiz questions. Here's the link that you will see on EDSB that I'd like you guys to check out all of. Let's check it out here.
stars can be 100 times more massive than the sun and emit thousands of times as much energy. Compared to these stars, the sun is actually a pretty normal mass, but that doesn't make its relationship to Earth any less special. Many planets are either too close or too far away from their stars to support life. Earth is in what we call the Goldilocks zone, or the habitable zone, where it is just far enough away from the sun to have the right temperature for life to exist.
So not too hot, not too cold, right? But if that sun doubles in size, what happens to that zone? What happens to the Earth?
And we're not the only planet like this. Scientists believe there are billions of Earth-like planets in habitable zones across the Milky Way.
And we will talk all about that here in the near future. Really exciting stuff.
In fact, in early 2017, NASA announced they found 7 exoplanets 39 light years away that might have water, and 3 of them are in their star's habitable zone. But all of them orbit their star closer than Mercury orbits the Sun.
So again, some things to take into consideration as you guys watch that. Really cool stuff. I always like infographic, animated videos. I think they give us good visuals, and they're quite, they catch the eye a lot of the time. So watch all of that. It's just 2 to 3 minutes. Nothing too long, too detailed there. All right, so let's go on to our first practice question of the day with our card questions. As you guys know, blank is the first planet inside the asteroid belt, while blank is the first planet outside the asteroid belt. Is it going to be A, Mars, Jupiter, B, Mercury, Jupiter, C, Mercury, Saturn, or D, Jupiter, Mars? Pause, take a moment to think about it. Could be a quiz question. Your answer is going to be letter A. Mars is the first planet on the inside of the asteroid belt, whereas Jupiter is the first planet on the outside of the asteroid belt. Again, Jupiter is the largest planet in our solar system. It's largely what anchors and keeps the asteroid belt intact. And keep in mind, the asteroid belt is also what separates the inner rocky terrestrial planets from the outer gas planets, right? Okay, our next video question, which I'm going to get to a little bit later. What I first want you guys to record here briefly is this idea of exoplanets, okay? So exoplanets, guys, are planets that orbit stars outside of our solar system. So as you just saw through our first video, little glimpse that we saw, scientists are discovering other relatively Earth-like planets that are within their own Goldilocks zones, right? Again, the planet's not too close to its star to where it's too hot, and not too far from its star to where it's too cold. But again, it doesn't have to be Earth-like per se. But those planets we all call exoplanets, right? So just any planet, it could be Earth-like, could not be Earth-like. Any planet outside of our solar system is going to be what's called an exoplanet, okay? And here we have another telescope that is discovering these planets. So the Hubble Space Telescope is looking at galaxies and other solar systems and nebulas, things like that. But we have what's called now the Kepler Spacecraft, really important. This is a massive telescope that is actually scanning other stars and scanning the planets as they orbit their own stars. So they see that brightness from that star, and they're going to look at kind of when the brightness gets a little more dim. This telescope is so strong and extraordinary. It scans and looks at that planet as it goes in front of its star, and it's going to measure how far it is, or whether it's in potentially the Goldilocks zone of its own solar system. So it's really just trying to look for other Earth-like planets. Pretty amazing, incredible stuff. So we need to know exoplanet, and you got to know the Kepler spacecraft, right? With that in mind, have we discovered other Earth-like planets yet? And have we discovered life outside of Earth yet? What might it be like? I'm going to go ahead and save that for another day. Really awesome stuff there. We'll check that out tomorrow. But let's get to our last video of the day, which is the Hubble Space Telescope video, all about its history and its creation. Number one, when again made in 1990, 30 years ago, when our scientists first created the Hubble Space Telescope. Again, HST is short for Hubble Space Telescope. What issues came about? And then two, how does the Hubble Space Telescope record images of distant parts of space? Again, we already answered it with our GoBlues. Hopefully that's a piece of cake at this point in time. But let's go ahead. Let me show you a snippet of this video. I believe it's from maybe the New York Times. Always really good. Let's see. Yep, New York Times. So let's go ahead. I'm just going to show you a little snippet of this video as well. Really cool historical stuff. I love history. We're going to look at a lot of awesome history stuff with NASA and space exploration coming up here soon as well.
When the Hubble Space Telescope was launched from the Space Shuttle Discovery in 1990, NASA called it the greatest advance in astronomy since Galileo.
Absolutely.
Instead, within days, it became a laughingstock.
Number one.
Hubble had an 8-foot diameter mirror, but a chip of paint on a measuring rod caused the mirror to be 4 millionths of an inch too flat, leaving the telescope with blurry vision. Hubble.
Okay. So there, that answers number one for you guys, right? Again, the mirrors were not aligned correctly. They were. I think what was said there, it was too flat, if I wasn't mistaken, and that caused the reflection of that light to not be completely balanced. And that's where we got those images of those other galaxies, right? We're in the Milky Way galaxy, but these other galaxies in different space, we couldn't see as well, and it had blurry vision, right? So you guys can go ahead and watch the rest of that on your own. Make sure you do that. It's really good stuff. I never try to show or put on long, boring videos. I like good, exciting videos, right? So please check that out so you have all of that in your notebooks for our quiz or for our notebook checks. Okay, let's go ahead and try to finish up here with our one thing I want you guys to write on page 5. Okay, so I'm just going to put page 5 right here. Okay, I'd like you to just title it Kepler's Laws of Planetary Motion. Nope. Okay, so let me go to the title here. We've learned all about the important figures, so we're going to skip through that. But just title page 5, again, page 5. Title that Kepler's Laws of Planetary Motion. There's 3 of them. We just need to know those. Really important stuff and easy to grasp once we break those down. So we're going to skip all this stuff here. This is old stuff. We don't need to repeat old stuff. All right, so Kepler's first law. So all you need to write down is this. For his first law, and let me move my little screen here. For his first law, okay, planets move in elliptical orbits with the sun at one of the foci. What does that mean, okay? Well, all that means, I think my picture, yeah, here we go. All that means, guys, is that, again, as you've heard before, planets orbit in a long oval shape, not in a circular shape. And not only that, the sun is not at the center, okay? Not at the center of the ellipse, of the elliptical. It is at the edge. We call these the foci. Again, go ahead. I'd like you guys to probably just sketch this in your notebooks and just put foci. Foci is not the center. It's kind of one edge or the other. So go ahead, write this down, all of what's in red on page 5 in your notebooks. Page 4 will be tomorrow's Go Blue. So don't worry, skip that page. We'll have the Go Blue on that tomorrow. And you guys will go ahead and just have number 1, first law of motion. Planets move in elliptical orbits. They go in an oval, as you can see in this GIF down here. And then we see again, yep. So the sun would be at the foci, okay? And then lastly, just write what's in blue on this slide as well. There's one point called the aphelion. So go ahead in your drawing. I need you guys to label aphelion and perihelion. So just understand, the aphelion is where the planet is the farthest, okay, from the sun in the orbit. That's the aphelion. So think A, away, aphelion, right? And the perihelion is where the planet is the closest to the sun, okay? So go ahead in your sketch from earlier here. In your sketch from earlier, you drew the orbit, the elliptical. You drew where it said foci, where the sun was at. Well, now on that same ellipse, all I want you to draw on that in your notebooks is to draw the aphelion, the point farthest away, and the perihelion, the point closest. Don't be surprised if you see that on Thursday's quiz. I'm just Thursday or next week's quiz, you will definitely be seeing that. So make sure you wrote that down. Okay, so aphelion, farthest point away. Perihelion is the closest. Okay, I think, guys, that just about finishes what we have for today. Let me go back to my other main kind of procedures here and see if I think that covered everything I wanted to cover for today. Okay, so we will get to other Earth-like planets another day. Really awesome, exciting stuff. that kind of concludes that. I only wanted to include one practice question for today, guys. But again, keep up with your work. I reopened the quiz for some people who had technical issues at home and they're just now getting internet or this and that. So again, take that quiz. Otherwise, after this week, it'll be zeros for those who have not taken it yet, pending an emergency situation. And we'll have our next quiz and our next notebook submission up very soon. And then the submission link for the vocab is already up, and I've got people turning that in. So again, turn those things in. Otherwise, guys, message me with questions, any concerns. I'll get back to you within 24 hours. Again, this is Mr. Campbell signing out. You guys have an awesome day and keep up the hard, good work. Take care. And again, that concludes our lesson for today.